Welcome back. I wanted to make a quick video going over some special kinds of triangles, specifically when you have a 30, 60, 90 degree triangle and a 45, 45, 90 degree triangle. So obviously if you have these kinds of triangles, they're proportional. They're always going to be proportional. And the proportions are 1, 2 in the square root of 3 for a 30, 60, 90, and 1, 1 in the square root of 2 for 45, 45, 90. Let's go ahead and start with a 30, 60, 90 triangle. So the hypotenuse is always double the size of the smallest size. And the middle size is always proportional to the square root of 3. And so what does that mean? Well, first off, what is the square root of 3? Well, the square root of 3 is just some random number. So we can even plug it into our calculator and get the actual number here. And it'll just give you the square root of 3 because it's a rational number. But we can flip it and turn it into the actual number, which is about 1.7, and then it goes on forever. So it's about 1.7. Now I could write out the entire decimal, but it's a lot shorter just to write the square root of 3, which is why we do. And so whenever you see a number like this, like the square root of 3, like the square root of 2, just know it's a shorter way of writing just a really long decimal. And that's really the only reason why we use them. But anyway, let's go ahead and move on. Let's say then, what if we had this or let's say that this hypotenuse was 4. If this hypotenuse was 4, well, let me pick a different color than 4, or than purple. So if the hypotenuse was 4, well then this side would have to be half of that, so it would have to be 2. And this side would have to be whatever 2 times the square root of 3 is. What if this side down here was, I don't know, 7? Well, this side would be something like 14, or not something like, exactly 14, and this one would be 7 times the square root of 3, whatever that is. And that's just some random number. We can even figure out what that number is if we were so inclined. We could say, what's the square root of 3 times 7? And it's 12.1 about, but it's a long decimal. So instead of writing out this really long decimal or rounding and getting an answer that's not exact, we could just say, well, hey, it's 7 times the square root of 3. It's a little bit shorter and a little bit more exact. And that's the reason why we do that. That's why we use those rational numbers. But we can do another example here. We could say, what if we say, I don't know, 20.4. So 20.4. Well, this one would be twice that, which would be what, like 40.8? And this one would be whatever 20.4 times the square root of 3 is. And again, if we were so inclined, we could figure that out just by typing it in our calculator. And when you look at a 45, 45, 90 degree triangle, we see something very similar. Since these are both the same angle, their opposite sides are equal as well. And the square root of 2, again, is just some random number. So we can even figure that out if we were so inclined. We could say the square root of 2 and then flip it. And we get about 1.4. And again, it's a really long decimal, so it's, instead of writing out the really long decimal or rounding and not getting an exact answer, we just say the square root of 2 because it's shorter. But just know it's some random number. But what if we chose a different number? What if we said this side was 3? Well, if this side was 3, then this side would be 3 because they're equal. And that would make this one 3 times the square root of 2, or whatever that number equals. And what if this side was, I don't know, the square root of 2? Well, then this side would have to be the exact same, which would be the square root of 2, which would make this the square root of 2 times the square root of 2, which is just the square root of 2 squared, which is just 2. So what if I was given some random triangle? Okay, so what if I was given some triangle? Let me get my pencil out. Let's give this angle, let's say it's a 30, 60, 90, so this is 60 degrees. And let's say, in this example, we find out the hypotenuse here is, I don't know, 11. And I say, what is this side? Well, we could say, well, we're given the cosine and the hypotenuse, so we could do the cosine of 60 equals yada, yada, yada. And this is the symbol for yada, 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 by the way. And we can go through all that math, or we could real quickly realize this is a 30, 60, 90 degree triangle, so it's just half of 11, which is 5.5. And that makes this side whatever 5.5 times the square root of 3 is, and we're done. We could do the same thing with a perfect triangle, with a 45, or not perfect, but 45, 45, 90. We could, well, it doesn't really matter what the color is. And what if I told you that this side, well, let's go ahead and label these as 45 degrees, 45, and this one is the same, 45. I say that this side is some random number, I don't know, 7.37. Well, then this side would have to be 7.37 as well, and that means the hypotenuse would have to be something like 7.37 times the square root of 2, and we could type that into our calculator if we wanted to know what that was. And so whenever you see a 30, 60, 90 or 45, 45, 90 triangle, you can do these quick tricks instead of doing sine, cosine, and tangent. But if you want to do sine, cosine, and tangent, and a squared plus b squared equals c squared instead, you're more than welcome to. I won't get mad at you. I won't take off. It's just more work. This is just a quick trick that you can memorize.